Welcome to This Explainer. Today, we're turning dry math into striking physical realities. Let's dive right in. We're contrasting massive global populations right down to razor-thin margins of physical error. Ready? Take Nigeria. Back in 2014, its population hit a staggering 177,156,000. To score exam marks, shrink that into standard form. It's 1.8 times 10 to the 8th. But what if we've got to multiply two massive planetary scale numbers together? Sounds terrifying, right? Easy. Multiply the bases, add those indices, and adjust. Boom, 3.0 times 10 to the 20th. So what happens when real-world physical measurements just aren't perfectly exact? Let's find out. Imagine a strict engineering weight limit, a 2,400 kilogram car towing a heavy 1,460 kilogram caravan. To find the absolute lowest possible total mass, we contrast and combine their extreme minimum bounds. Adding those gives us a guaranteed physical lower bound weight of exactly 3,085 kilograms. Now look at this realistic architectural blueprint. Every single edge is cut to the nearest centimeter. To maximize the shaded area, we take the largest possible outer boundary minus the smallest possible cutout. Subtracting that tiny cutout from the maximum outer area yields exactly 295.5 square centimeters. Pretty cool. But how do these proportional extremes actually apply to everyday, real-world markets? Let's shift gears. The exact same math we use to share sweets applies directly to commercial spice trading. If Georgia's 5 parts equal 30 sweets, 1 part is 6. That means 42 sweets total. Applying that logic to commercial spices, a 3-to-2 ratio means our missing variable x is exactly 40. Finally, if 200 grams of spice costs 85 cents, what's the cost for a full kilogram? Multiply by 5 to scale it up. That gives a precise real-world cost of $4.25. From planetary scales to architectural bounds, contrasting these extremes is your absolute key to crushing the exam.